one. And that is a utility which I just could not look at myself in the morning in the mirror unless I told you about this command. This is one of the most useful commands in Linux. To the best of my knowledge, previous versions of this course have not featured this command, but it's such a workhorse command that I really felt I needed to talk to you about it. I'm going to give you a very brief introduction, ladies and gentlemen, to the find command. Now, you will find, no pun intended, more extensive discussion of this command in the Sobel book. In the third edition of the Sobel book, I know different people are working with different editions, but in the third edition of the Sobel book, you will find it on pages 804 to 809. And I strongly suggest that you take a look at those, and secondly, that you try experimenting with some of the syntax. Excuse me, 804. I said 806. It's actually incorrect. It's 809. So I stand corrected. Let me edit this on the fly. Okay. So the purpose of the find command, as its name suggests, is to locate files which match a certain criteria, but more than that, it's to perform commands, perform actions on them where desired. Okay? And it does so based on criteria that we specify. It does so based on conditions that you build up as part of the arguments to it, the arguments to the find command. This is an incredibly useful utility. It's one that has an absolutely terrible syntax. And perhaps there's a reason that I'm showing this to you after drop date. Because although a fitting day, I should note, would have been to show it on Halloween, because the syntax is one that will frighten young children. Let's take a look at some of that syntax. This is not for the faint of heart, but it's incredibly useful. Okay, so suppose I want to find files underneath the current folder that were accessed more than a day ago and are fully accessible by all people. Well, let's unpack that. Fully accessible by all people, that maps into permissions, right? I want to find something that's read-write and execute access by everyone. So to certain permissions, you can see this perm minus 777. That's not a reference to our sister city in Siberia, perm. It's a reference to that there's a criteria involving permissions, and it says they need to exactly match 777. There's actually a plus option that says it needs to include at least one of these bits. That's kind of similar, you can read about and so on. Secondly, there's a part of this criteria that I'm specifying this, they need to be accessed more than a day ago. So I could say minus a time, a indicating access, plus 1, meaning more than a day ago. I actually can't tell you off the top of my head whether this is greater than or equal to or exactly greater than. It's a continuous quantity, and they don't really sweat that detail in the documentation I've looked at. But in any case, this is minus a time plus 1, meaning 1 day or more. That's part of the criteria, so it needs to match this criteria, minus a time. So it has to be at least 1 day old, and it has to have permissions minus 777. The minus there indicates they match these permissions quite precisely, not just include these bits. And then I define dot. The dot indicates what, folks? The current folder. So I'm finding all files in or beneath. By beneath, I mean they can be in subdirectories that match these criteria. And by implication, I don't say what to do here. By implication, it's printing out those files. So they say to get 20 minutes of exercise a day. So so minus a time. Hopefully, no one's running factor on this right now. So if I did just minus a time plus 1, these are all files accessed more than a day ago. As you can see, I maintain a fairly copious set of files in my directory. If I do perm minus 777, let's see which things are, no, I don't want to do that. For this, oops, minus perm, excuse me. If I want to look at all things whose access is set to 644, I don't find anything. How about, 444, how about 644? Okay, all of these have that level of access in them. So here I've found files beneath this that are more than a day old and have this, this sort of access permissions. Okay, suppose now I want to find and execute, suppose I want to find files in the 214 folder, which are less than 10 days old, and less than, oh, I said 10K size. I actually said 20K size in the command, so I should correct that. So they're less than 20K in size, and they are less than 10 days old. So let's unpack that first. So these are the criteria, minus n time. So this is the last modified time is less than 10 days, and the unit of this is days. The size is less than 20K, hence minus 20K, just like this was minus 10K, less than 10 days. And I want to find all .o files, so I have a criteria for the name .o. Why do I have this quotes there? Okay. Technically it's not a regular expression, but you've got the essential ideas here. I want to give this expression to find. Okay, find needs to know about the star.o. If I put star.o without quotes around it, does find ever see the star? No. That gets expanded by whom? The shell. The shell takes care of expanding it before find sees it, before it's a glimmer in find's eye. If I have no quotes around it, before it's a glimmer in find's eye, that star has been expanded by the shell to include only files where? In the current directory. So I need the quotes around it to tell it, hey, find. Go look for this pattern, the star.o, for files in any file beneath 214, any file or folder beneath 214. I don't want it to just consider files called star.o in this folder. I want it to consider them all in that directory. So, ladies and gentlemen, I could execute that, and then on those files, I actually want to execute ls minus l on them. I want to see their full information. So I can do a minus exact ls minus l, and this begin curly, end curly basically tells it, okay, substitute in there the name of the file whose criteria is being examined. So we'll actually we'll do ls minus l in the particular file involved that matched all of these preceding criteria. It would never have gotten to this point of the exec unless it had matched the name, unless it had matched the modified time criteria, and unless it had matched the size criteria. It has to go through that gauntlet, one after the other, in succession, before it will execute this exec. And exec is satisfied. It satisfies the exec if it returns a normal status code, a 0 status code, which is if it worked properly. It countered no error. So this is ls minus l on whatever file is being examined, and it finds two such files, ladies and gentlemen. It finds state.o and queens.o, which are in my folder. So you can imagine this unpacking this into two commands. One would be find these files first, and secondly to do an ls minus l on those by hand, but this packs it all into one command. Any question on that? Yes?
What's with the semicolon or the backslash semicolon?
Okay, backslash semicolon, we'll get to that in a second. This terminates the exec, so it tells it, so exec could be some long command, right? We could have ls minus l, and it could type it into something else or what have you, and it could be composed of many, quite an articulated sort of command sequence. And it needs a semicolon to be told, hey, that's the end of the command, because you might have criteria after that as well. Okay? That if this is passed, if it returned normal status code, then you don't want to examine other criteria. Okay? Question?
That side effect, is that the one that might kind of files? You mean like changing access?
Oh, yeah. So this top one, so access time for a file is modified if you actually go and inquire as to its access time. So that's why.
If you were to run the command back, you can output once, and if you run it again, you can
Correct. Right. Because by running this command, it has peaked at what its access time is, and as part of doing that, its access time gets updated. That's not true for this modified time at the bottom, because it doesn't modify the file if you check its modified time. It doesn't modify the file if you check its access time. But it does modify the file, it does modify the access time of the file if you, in other words, the last time the file was read gets modified, gets updated if you even check to ask, when is the last time you got read? That's a weird factoid, and I don't mean to distract people with it. It's just, you should be aware that an access time actually does update that access time. Yeah.
Instead of using the weird exact syntax, could you just type it to the ls minus l?
You could, in that case, do it will list those, and yes, I think that would work fine actually in this case. Not all cases. There may be some things, some cases where the commands would not take it in for standard input or whatever, but yes, I think in that case it would work. Hey, let's try it. Let's try it, folks. Okay, so let me copy this thing here, and I will excise that last little bit, and we will go and okay. Hey, am I live here? Oh man, Tux World. Okay, I suspect I'm not alone in having dealt with these sort of things. Okay, so I'm going to do this, and let's go do ls minus l coming out of this. So the question is, does ls minus l? Nope. No, it does not do that properly. So this is the output here, and it is not properly handled as standard input to ls minus l. That's an entirely different matter. Okay, so some of the stuff we'll be talking about with command substitution. We'll get into that later. Okay, so these are some incredibly useful findings. Yes, question. The curly brackets basically provide, so great question. So here we have this find going through files and seeing if they match success criteria here, right? That's how find works. It applies these criteria as specified on the command line to the files being looked for, in this case in the 214 directory here in the current directory. So for each file that it's finding at or in or beneath this 214 directory, it's applying these criteria in turn. They're next to each other, so by implication they are ANDed together. You need to pass this criteria that it needs to match .o. It needs to have a modified time of less than or equal to 10, and it needs to have a size less or equal to 20K. I'm actually not sure about the equal. And so if it matches each of those criteria, under those conditions, we'll get to this exec, and it will substitute the name of the file or the location of the file here, okay? And then the ls minus l will be done on that, okay? So this gets the file path, this begin bracket, curly bracket. So, you know, if I had done something instead, like if I'd done echo, for example, that, so, hey, come on. If I had done minus exec echo, right, this, and I can again quote this, and then it will just print out the names of the files. If I wanted to cat them, ain't that something? Well, I'll be. Wow. I really wouldn't have expected that, but all hail Putty. So great. So this is giving you that make sense? Okay. Okay, let's just talk a little bit more about this and we can move on. So here's some particularly useful find options. Minus name, pattern we've seen, minus m time, minus a time, size. And you know, you can specify the size. This means one of, and sort of, this regular expressions index is my, just indication of what characters can follow. C stands for characters, K for kilobytes, cap M for megabytes, cap G for gigabytes. So, you know, do I have any gigabyte level files in my folder here? Let's go see this. So if I do minus size plus 1G, it will look, and I actually don't know if there will be anything, but it's take a while. So this size allows us to look. This could be plus or minus. So if I want to look for things less than that, let's see if there's anything more than 100 megabytes here, right? Okay, yeah, here we go. There's some stuff. You'll notice there's a thing like exec that's called OK that will actually confirm whether or not you want to execute this command for a given file. It will actually say, should I do this indeed? So for example, if you had minus exec and you have a remove command, maybe you want to do it as an OK command instead, so it'll actually check with you, do you really want to do this? Print will print things out. You can actually take Boolean operators on these things. So again, the syntax is atrocious, but you can take an or for criteria rather than the and that's implicit by juxtaposing them. So far we've had minus mton next to minus size, and so it has to apply both, and it has to match both to satisfy the criteria. Here, we could actually do minus or, so to match one of them. We could have an exclamation point to indicate logical not. So we wanted to reverse this criteria. We can ask what the type of the file is, whether it's a binary file, whether it's a regular file, whether it's a directory, and we can ask for its permissions, which again has a plus syntax. Okay, so these are useful find options. A few tips for this. Find syntax will throw you off if you don't use it a lot. So be sure to include quotes to terminate a quoted semicolon. To terminate the minus OK or minus exec. That means you can do backslash semicolon like I did, or you can do a quote around it, a quote character. Okay. Remember that you can use this begin curly, end curly to indicate the current path in file being evaluated. And be sure to quote the file name patterns given to minus name, because they need to be known about by find. They need to be applied, ladies and gentlemen, to each successive directory, okay? To each successive directory to which it's applied. So be sure to quote those. They're not just expanded in the current directory, like star.o, if you have no quotes around it. They have to be applied to each subdirectory. So it needs to know about the star.o. And then pluses and minuses often mean more than and less than. And I'm not sure about equal to. I'd have to look into that more. Okay? So find. Find is your friend. You're getting a lot of friends for this class, aren't you? As well you should. Okay, that ends our discussion, our glimpse of find. And with your leave, I may... Oh, where are we? Here we are.